Assalamualaikum and hello, my name is Muhammad Aliuddin. In this video, we are going to design the arithmetic logic unit that stands for ALU, that is part of the reduced instruction set architecture, which is RISC-V. In our ALU design, we consist of multiplexer, arithmetic unit and register, and then I will talk about the 4-1 multiplexer. For 1 bit of 4-1 multiplexer has 2 control signal and 4 inputs, which is I0, I1, I2, I3. Will connect to AND gates respectively. For the control signal S1, S0 will connect to the second and fourth AND gates, and not S0 will connect to first enter AND gates. For S1 will connect the opposite S0 connection. Finally, all output from AND gates will connect to OR gates. After we connect everything, we need to run the circuit. If it doesn't have any problem, we'll press the file and press the create or update. Then we press the create symbol files for current file to create the 4-1 multiplexer gates and save it. To build a 4-bit 4-1 multiplexer, we need insert the block symbol of the 1-bit 4-1 multiplexer that we made already and connect to the circuit which have 5 inputs. We connect the I03 to I33 respectively, and S0 to the first multiplexer. Continue the following step with the change of the input to I02 to I32 and S11 to last marks. It is important to label the bus line correctly. The output will be Y0 to Y3, and lastly we will do the same step and create symbol for the file 4 bits. Next is the arithmetic unit that will perform additions and subtraction for a 4-bit data input. A full adder consists of 2 data inputs, A and B, with a carry input. This produces 2-bit outputs that are carried out and summed. Based on the truth table of full adder, we can get this logic expression. Cout is A and B, or A and C, or B and C, while sum is exclusive or B, exclusive or A, exclusive or C. We can proceed with the same method previously with multiplexer by exporting this to a block diagram. We can still create a customized for the adder and subtractor, but we do a 4-bit adder subtractor instead for a lesser logic gate. And then we add 4 adders in our circuit, and since our data input has a 4-bit, we will name it as A3 to 0, and then make sure to put a NOT gate, as this will turn to 0 to 1 and then 1 to 0 for the operational plus and minus. And then we create a bus line that connecting to input A in each full adder and name each line A0 to the A3. For our 4-bit D inputs, we are connecting each of it with a carry in input, connect exclusive to B, then first Cout to the second adder, and then respectively, but you can ignore the final carry out bit signal. Same goes for the sum from S0 to S3 using the bus line. Lastly, export this block to a block symbol. And now let's look how to design for a register. We need to have 3 inputs, which are D3 to 0, clock, and reset. Now we have 4-bit input, so we need to have 4 D flip-flop that we need to use in this register. We connect all input D into D flip-flop by using a bus line and label all the line with their respective number, but all the clock and resets are connected together with their resulting circuit into the flip-flop. We can connect all the output from the flip-flop together in the bus line and label it as Q3, Q2, Q1, Q0. We combine the with and output 3 to 0. We will export this as a block symbol also. Finally, we can combine all blocks together to build a ALU design. So now we will run the waveform. We can go to the file and we press new and we choose this university program VWF. We click it and we can right click and choose node filter and click list. So after all in-person outputs pop up, press OK. So the value is already be set up. So this input for the ALU, for the input, it will come out this output. So when the reset 0, so there's nothing happen, so this will be 0 0 0. So when the reset is 1, the operation will happen. It work with clock. When the clock at the positive edge, it will get the value. So when the selector is 0 1, which means it will choose A1, which is 1 1 1 1. Then for B selector also 0 1, therefore it choose 0 1 1 0. When ALU OP is 0, it means it is subtraction operation, so A minus B in 4 bits operation will result Q1010. When its ALU OP is 1, it means addition, therefore A plus B. That's all, thank you.